This is the test 5 review. So the first one, find all zeros, enter the zeros separated by commas. So for this example, you're going to have to use the rational zeros theorem to determine what options you have in order to use synthetic division to break this down into a quadratic, or you can try factor by grouping. Kind of looking at it, maybe you can do factor by grouping. So we can try that here. So if I do that, and I'm going to use the extra space down here for number 1. X cubed minus x squared plus x minus 1. So you can always try factor by grouping and see if it works. Sometimes it may, sometimes it may not. Both of these have an x squared in common. So if I divide out an x squared, what will be left is x minus 1. In the second pair, I have nothing in common. So I could divide them both by 1. So I would write down plus 1, and that would leave x minus 1 in common. And it looks like it's going to work out since the x minus 1s are now in common. That would be our greatest common factor, and x squared plus 1 out here would give us that other factor. So here is how that factors. If we're finding zeros, that means we're setting it equal to 0 and solving. So we have x minus 1 equals 0. So that'll give us a 0 of 1. And then we have x squared plus 1 equals 0. And we would solve that by subtracting 1 from both sides. We would have x squared equals negative 1. We would take the square root. The square root of negative 1 is an I. Don't forget to put plus or minus. So you would have x equals plus or minus I. So we are expecting 3 zeros because we had a degree 3 polynomial, and we got 3 zeros, 1, I, and negative I. All right, let's look at number 2. So for number 2, find all zeros, enter the zeros separated by commas. So we can try to factor by grouping here. This one will not work. So we won't be able to use the same process as number 1. Instead, we will have to do the P over Q method. So P is negative 7 or 7. Q is the coefficient of the leading term, so it will be a 1. So our possible P over Q's, that's all the factors of P, so that's 1 or 7, over all the factors of Q, which is just 1. So when we do that division, we get plus or minus 1 and 7. So there's our possibilities. So now we have to figure out which one works using synthetic division. So I'm going to start with a 1, and I'm going to do synthetic division. So 1, negative 7, 13, negative 7. Bring down the 1. 1 times 1 is 1. I add and get negative 6. Multiply, get negative 6. Add, get 7. Multiply, get 7. Add, get 0. So I was lucky in that I guessed a 1 and 1 worked. That was purely coincidence. If it didn't work, then you would pick another number from the list. So you could try negative 1, you could try 7, or you could try negative 7. So 1 worked, so I'm going to put 1 up here on my answer line. And then I'm left with a quadratic quotient. So that quotient would be 1x squared minus 6x plus 7. To find the 0, I would set it equal to 0, and then factor or use the quadratic formula to solve. So if I factor it, let's see if it factors. It has to multiply to get 7, positive 7, and add to get negative 6. So 7 and 1. But that would only work if the signs were different, and the signs have to be the same. So it looks like this one is not going to factor. So we want to use the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, so we'll have 6 plus or minus the square root of 36 minus 28 over 2. That will be 6 plus or minus the square root of 8 over 2. 8 will break down into 4 times 2. 4 is 2 times 2. So a pair of 2's come out as 2 and a 2 stays under. So this will be 6 plus or minus 2 square root of 2 over 2. And then we have a common factor. If we look at our heart here, they can all be divided by 2. So this would be a 3, this would be a 1, and this would be a 1. So we would get 3 plus or minus the square root of 2. That would be 2 solutions. So we already found one solution, which was 1. And now the other 2 solutions are 3 plus or minus the square root of 2. So 2 methods, method 1, method 2. Method 1 only works sometimes. If you can use factor by grouping, it's much easier. However, it's more rare that that works. Usually you're going to have to do the method we use for number 2. Okay, number 3. I'm going to erase some of this so it's not so cluttered here while we look at number 3. So consider the function. It's a rational function. We want to find the equation of the horizontal asymptote. So we're just looking for the horizontal line. So here's the horizontal line. It passes through the y-axis at 1. So the equation, because remember you need to have an equation, is y equals 1. And that's because it passes through the y-axis at 1. Okay, the vertical asymptote is the line going up and down. It passes through the x-axis at -1. So we would say x equals -1. So those are the asymptotes. Don't forget to write equations for those. Which of the following would be the domain of the function? So the domain is only the x values. So the x values go from -infinity until it almost gets to that vertical asymptote, which is -1. So that's going to be -infinity to -1. And then it starts again almost at -1 and goes to infinity to the right. So we're looking for 2 intervals that hug -1. And it looks like B would be the correct answer. Okay, number 4. So for this one, we are given a function and we're asked to find several things related to the function. So first, the domain. So the domain relates to the denominator. So in a fraction, we don't want the denominator to be 0. So we would set it equal to 0 and solve and see what we get. So hopefully this factors. So multiplies to get 16 and adds to get -10. I believe -8 and -2 would work. So that means x minus 8 equals 0 or x minus 2 equals 0, which means we'll get x is 8 and x is 2. Now these values would be the values that give 0 on the bottom. We don't want that to happen. So these are the excluded values. So to give the values that we actually want, we would write interval notation. So we want -infinity until the smaller of the 2 numbers, which is 2. With parentheses, because we don't want to include 2, we would start again at 2 and go to the next larger number, which is 8. Then we would start at 8 and we would go to infinity. The y-intercept. So we find the y-intercept by letting x be 0. So let me erase this. Okay, so y-intercept, we let x be 0. So we'll have 0 squared minus 5 times 0 plus 6 over 0 squared minus 10 times 0 plus 16. Notice everything with an x cancels out because it's just 0. So that leaves 6 over 16, which reduces by 2. So that would be 3 over 8. So that is our y-intercept when x is 0, y is 3/8. Okay, so next we want to find the x-intercept. So the x-intercept is where y equals 0. Now, y equals 0 means the whole fraction is equal to 0. But remember, the bottom actually can't be equal to 0. The only thing that could be 0 would be the top. So we're really just interested in when is the numerator 0. So we would factor this. So this would be maybe 3 and 2 if they're both negative. Negative 3 times negative 2 is positive 6. Negative 3 plus negative 2 is negative 5. So I think that works. So x minus 3 equals 0, or x minus 2 equals 0. So x is 3, x is 2. So these are both our x-intercepts. Oh wait, did I make a fatal mistake? I did. Okay, so right now what I'm saying is, oh look, I got 3 and 2. But let me show you where I went wrong here, because I did make a mistake. Nothing is wrong with my work. However, I forgot that in the beginning, I should see if the top and the bottom have common factors that I could cross out, because those are holes or removable discontinuities. And that's going to lead to a difference in my asymptotes and in my x-intercepts. So the top I factored, I erased it, and the bottom I factored. When I found the domain, I erased that. But the top factored into x minus 2 and x minus 3. And the bottom factored into x minus 2, x minus 8. Notice that the x minus 2's are in common. So here is my hole, or removable discontinuity. So that's what you need to remember, because that changes. Now we don't have an x-intercept at 2 because it's a hole. Okay, so that's gone. So the hole, the x value of the hole is 2. So when x is 2, there's a hole there. Again, you find that by taking the factor, setting it equal to 0, and solving. So the x value is 2 for the hole. So only one x-intercept remains, and that's for the x minus 3. So don't forget to do that, right? The vertical asymptote, you find the vertical asymptotes by setting your denominator equal to 0, each factor, so not including the whole. So x minus 8 equals 0 would give us the vertical asymptote x equals 8. They already have the x equals, so I'm just writing 8. But remember, this is an equation. And then the horizontal asymptote you find by using the rules. So you look at the degrees, you compare the degree of the numerator to the degree of the denominator. In this case, the degree of the top is 2 and the degree of the bottom is 2. So those match. So when they match, you look at the leading coefficients and you make a fraction out of those. So it's 1 over 1. So y equals 1 is the horizontal asymptote. The oblique asymptote, it doesn't exist because we have a horizontal asymptote. Okay, next, number 5 is similar to number 4, so I'm not going to go through this whole thing. One difference is the horizontal asymptote, so I would like to point that out. For this one, the horizontal asymptote, you're comparing the degrees. So the degree of the top is 1, the degree of the bottom is 2. Since the degree of the top is smaller than the degree of the bottom, your horizontal asymptote is automatically y equals 0. So that's just the rule. If the degree of the top is smaller than the degree of the bottom, horizontal asymptote at y equals 0. The rest of the things can be found in the same way we did for number 4. Number 6, we have another one, same idea. So I'm going to go move on. Number 7, these are kind of messed up here. They're so spread out. Okay, I think this is number 7. Select the choice that is a graph of the function. So what you want to be able to do is identify where the asymptotes are, because that's going to separate the graphs. So you can see we've only got, oh, these run together. Okay, so we've got 4 choices. So the first thing you want to determine is where the vertical asymptote is and how many you have. So in this case, the vertical asymptote is found by setting the denominator equal to 0 and solving. So x equals -3 is our vertical asymptote. Okay, and then you can look at your horizontal asymptote. So the horizontal asymptote, since the degree is the same, they're both 1, you look at the ratio of leading coefficients. So that'll be y equals 1 as my horizontal asymptote. So this is what I'm looking at as I go through. So A, let's just first look at the vertical asymptote. Vertical asymptote at -3, that one's good. This one has a vertical asymptote at +3. So that's not going to work. So it definitely cannot be B. Okay, so it's not B. C has a vertical asymptote at +3. So it definitely cannot be C. Okay, so not that one. D has a vertical asymptote at -3, so that one's looking good. So now our choices are A or D. So let's look at the horizontal asymptote now. Here, the horizontal asymptote, if you look, it looks like this line goes down below the axis. So if I'm looking for a horizontal asymptote at 1, this one goes right through that. So this one's not a good candidate. So let's look at D. If I'm looking for a horizontal asymptote at 1, it fits nicely between what's drawn. So choice D is the one that we would pick. All right, number 8. Use the given polynomial function to identify the zeros and the multiplicity of each zero. Okay, so each factor is going to give us a 0. The 0 is always the opposite sign of the factor. So if we have x minus 8, the 0 is going to be +8. And then remember, the multiplicity is the exponent. So there's not an exponent written on that first factor, so it's understood to be 1. Next, we'll have the 0 of -3, and the multiplicity is 3. Okay, and next we will have the third factor. The opposite is 5, and the multiplicity is understood to be 1. All right, number 9. Use the given polynomial function to identify the zeros of the function. Okay, so this is really similar. So I'm going to skip this one. The only difference is that we have a 0 of 0 here. So make sure you include 0 as a 0 and the multiplicity 2. And other than that, the same thing will be done for the rest of the factors as above. Number 10, determine the behavior at each X-intercept. Write each intercept as an ordered pair and the behavior as cross or bounce. Okay, so the 0 associated with this one. Oh, I see there's 2. Okay, got it. So the 0 is 0. So that means the ordered pair will be 0, 0. And since the multiplicity is 2, this will be a bounce. Next, we have a 0 of 5. So remember what that means is that if y is 0, x is 5. So for all of these, we're finding the x-intercept, meaning the y value is 0. So you're putting your 0 as your x value, and the number 0 is your y value. Since this exponent is odd, this will be a cross. Okay, next we have x plus 7. So the 0 is -7, so it'll be -7, 0. Since the multiplicity is an odd number, the multiplicity is 5, this will be cross. The next one, we have 6 as the 0, so 6, 0. The multiplicity is 4, that's even, so it will be a bounce. The degree of the polynomial. What we do to find the degree of the polynomial is we add the multiplicities together. So the multiplicities we have are 2, 5, 5, and 4. So when we add all those together, we get 16. So the polynomial is degree 16. Number 11, write an equation for the polynomial graphed below. So it doesn't have to be an exact equation. I'm going to be looking to see that you included the correct factors and that you included the correct sign in front. Those are the things that I'll be looking for. So if we're just writing an equation, we would include a factor for each zero. So the first zero that I see is -4 because it crosses the x-axis at -4. The factor associated with that is the opposite sign, so since it's -4, it'll be x plus 4. The next zero I see is -1. The factor for that will be x plus 1. And then the next zero is 1, so the factor for that will be x minus 1. So I'm going to include each of those. Then I have to look at how it's interacting with the x-axis. So for this one, at the -4, it's just crossing straight through. So the multiplicity would be an odd number. So I'm going to just say 1. At the zero of -1, it's crossing straight through. Again, that means it's odd. So I'm going to use a 1 exponent. And then at 1, it's not crossing. It's bouncing back down. It's staying below the line. So that means it needs to be an even exponent. And I'm going to use a 2. So any even exponent you could use. I usually use the smallest exponent that's either even or odd. So I have x plus 4 to the first, x plus 1 to the first, and x minus 1 squared. If I want to know the degree of the polynomial, I would add up all of the multiplicities and I would see that I have degree 4. Now, the reason I looked at that is because I want to look at the end behavior. So notice both ends are going down. It's degree 4, and both ends are going down. That's associated with a negative in front. So you have to remember to write a negative sign in front of your polynomial. So this is what I'm looking for. Number 12, write an equation for the degree 4 polynomial graphed below. This is going to be very similar to the one above. 13, pick the graph of the following function. So for this one, you're going to be looking for the zeros that match with the factors. So we're looking for a 0 of -3. So this one crosses -3, this one crosses -3, this one doesn't, so this is out, and this one doesn't, so this one's out. Okay, we're looking for it to cross -4, both of these do, and we're looking for it to cross -1, both of these do. So now we want to make sure that it's interacting in the correct way. These all have a 1 multiplicity, so it should be going straight through the x-axis. So this goes straight through, this goes straight through, and so does this. So this one looks like our answer. But let's just verify. If we look at the other one, we can see that it's actually bouncing at -4 and it's bouncing at -3. So that would not be the correct behaviors. So that would be incorrect. So it's this first graph that we would choose. All right, number 14, solve the polynomial inequality. Give your answer in interval notation. So for this one, you either need to make a lazy graph or you can do the chart method. I guess a lazy graph would probably be fine. So what you would do for that is you make your number line and then you put all of your zeros on the number line. So we have a 0 of 8, -4, and +4. So we want them to go in order. So -4 would go first, then +4, and then +8. And then we would draw what it would look like here, taking into account bouncing and crossing. So it bounces at 8 because it's a 2, right? Multiplicity 2 bounces, even bounces. These both have 1 multiplicity, so it's going to cross at both 4 and -4. And the end behavior, since this is even, it's positive, so it should be up, up. So that means it's up on this side. At -4 it crosses. At +4 it crosses. So it's like that. And then at 8 it bounces. Okay. So both of the ends are going up, which corresponds to a positive even. It crosses at -4, it crosses at +4, and bounces at 8. So now that we have our lazy graph, we want to look at the inequality symbol. This is a less than symbol. So we're looking for where it's below the x-axis, where it's below the line. So that's going to be from here to here. Everywhere else it's on the line or above. So it's going to be below the line from -4 to 4. So that's the interval that we would use to answer this question. All right, number 15, solve the polynomial inequality. So this would be the same thing. You would draw your lazy graph, but this time you would be looking for all the places where the graph is above the line. So anywhere where it's above the x-axis, you would use intervals for that. 16, same thing, you would use above the line or on the line. So for 16, you may have brackets. So why don't we go ahead and do that one, just because it's a little bit different. Not much different, but. So our zeros, x cubed gives us a 0 of 0, 8, and -4. So -4, 0, 8, because I have to put them on there in the order least to greatest. Since the multiplicity here is 3, it's going to cross there. It's going to bounce at 8. So let's see, cross, bounce, and this is a 1, so this is cross. Okay, and then I have to add up the multiplicities. So 3 plus 2 plus 1 is 6, so this is a degree 6. It's a positive, so that means my end behavior is up, up. So this is going to be going up. At -4, it crosses. So it's going to cross straight through. At 0, it crosses. At 8, it bounces. So actually, this shape looks a lot like number 14. So here's my lazy graph. Now I'm looking for where it's above the line because it's greater than, or on the line. So that would include everything to the left of -4. It would include all of the section between 0 and 8, and 8 and above. So it includes all of that side. So the only part it doesn't include is from -4 to 0. So if we're writing our interval notation for that, that would be from -infinity to -4. And since it has or equal to, we are including it, so we would put a square bracket. And from 0 to infinity. We don't have to say 0 to 8, union 8 to infinity, because 8 is also included. We can just use one interval here, 0 to infinity. All right, 17, solve, list all answers separated by commas. So we're solving this. We're going to have the square root of 3x plus 18 is equal to x. So we would start by getting rid of the radical, so square both sides. We get 3x plus 18 is equal to x squared. We subtract 18 from both sides. Yeah, we do want to do that, but we also want to subtract 3x from both sides. So let me go ahead and do both of those together. Since it's quadratic, we want everything on the same side, set equal to 0. So we would get x squared minus 3x minus 18 equals 0. And then we would try to factor that. If it doesn't factor, we would have to use the quadratic formula. So x and x, 6 and 3, negative, positive. Those will multiply to get -18 and add to get -3. So x minus 6 equals 0 gives us an answer of 6. And x plus 3 equals 0 gives us an answer of -3. The key here is to remember to check your answers, because you may get extraneous answers, meaning an extra one that doesn't actually work. So you need to check here. So by checking, you're verifying that it works. This is a necessity for these. This isn't an option. So 3 times 6 plus 18 square root is equal to x, which is 6 in this case. So this is 18 plus 18, which is 36. And so it's saying, is the square root of 36 6? Yes. So 6 does work. So I'd list 6 as an answer. Now I need to check the other answer I got. So the other solution I got was -3. So I'm going to check to see if that works. Okay, and I'm checking in the original equation. So 3 times -3 plus 18 is equal to -3. So that's going to be -9 plus 18 is 9. So I'm saying, is the square root of 9 the same as -3? No, the square root of 9 is +3. So those are not equivalent. So -3 is not a valid answer. So we would not write that in our answer set, just 6. So it's really important that you check your answers to these. 18 is going to be very similar. I'm going to skip that one. 19 is different because we have 2 square roots. So I'm going to go ahead and walk you through that. See, we really need some more space here. So let's make that happen. Okay. So for number 19, we have the square root of x minus 6 plus the square root of x minus 1 equals 5. To solve this, before we can square to get rid of the square root, we have to get one of the square roots by itself. So I'm going to subtract the square root of x minus 1. You could subtract either one, it doesn't matter. So the square root of x minus 6 is equal to 5 minus the square root of x minus 1. Now that I've isolated at least one square root, I can square both sides. So on the left, it just cancels out the square root because that's the whole side. But on the right, it doesn't just cancel it out. I've got to write it again and then FOIL. So 5 times 5 is 25. 5 times this square root would be -5 square root x minus 1. Now I'm going to FOIL out or distribute this square root. So it's going to be -5 square root x minus 1. So those will repeat. That middle part will repeat. And then this negative times a negative is a positive. And remember, you're squaring it. So this is just x minus 1. So now I'm combining like terms on that side. So 25 and -1 are like. So I would end up combining those. So on the left, I have x minus 6. On the right, I have 24 plus x. And then these two could combine together. So I just add the coefficients, so -10, and leave the radical the same. And now I want to get the radical by itself again. So I need to subtract 24 from both sides, subtract x from both sides. Thankfully, it cancels out on both sides. So I have -30 is equal to -10 times the square root of x minus 1. If both sides are evenly divisible by the coefficient of the radical, both sides are evenly divisible by -10, it's easier to divide. If it's not evenly divisible, like if I would have had -24 is equal to, and taken -24 divided by -10, that would not have been good because I would have had a decimal. So only do this if it's evenly divisible on the left-hand side. So it is, so we have 3 equals the square root of x minus 1. And now I square both sides. So I get 9 equals x minus 1. Add 1. So x equals 10. Okay, so that was a lot of work to get that. The ones with more than one square root is a lot more work. But do your best. If you make a mistake along the way, that's okay. You try it, and you get points for attempting. So go as far as you can, and if your work looks good and you make a small error, you can still get points. Now I said my solution was 10, but since I started with a square root, I have to verify that. So I do have to check. So I need to check x equals 10 by plugging it in. So I would have 10 minus 6 in the square root, and then 10 minus 1 in the square root equals 5. So this would be the square root of 4 plus the square root of 9 is equal to 5. The square root of 4 is 2, the square root of 9 is 3, and when you add those up, you do get 5. So 10 is a valid answer. All right, 20, solve the rational inequality. So for these, you can't really, you can, but I would not suggest doing the lazy graph. That's going to be way more work than necessary. Instead, use the test point method. So you find your critical values. Your critical values are found by all the factors of your numerator and all the factors of your denominator. So you set each factor equal to 0. So your numerator is x minus 4. You would get x equals 4. So that's one critical value. Another critical value comes from the denominator. We have x plus 2 equals 0, so we get x equals 2. So these are your two critical values. So you put your critical values on your number line in order from least to greatest, and then you choose test points. So your goal here is to decide which interval works. So you're going to have test points. So pick a number that's less than -2. That could be -3, -4, -5, etc. I picked -3. Pick a number between -2 and 4. 0 is in there, so I'm going to pick 0. And then you have to pick a number larger than 4, so that would be 5. These are the points that you're going to plug into your inequality and see if your result is true or not. So I'm plugging -3, so -3 minus 4 over -3 plus 2. And I want to know, is that greater than or equal to 0? So -3 and a -4 is -7 over -3 and 2 is -1. That's going to divide out and give me 7, positive 7. So is positive 7 greater than 0? Yes, it is. So I would include all of this in my answer. All right, now I'm going to check my next interval where I'm plugging in 0 for x. So 0 minus 4 over 0 plus 2, and I want to know, is that bigger than or equal to 0? So this is -4 over 2, which is -2. So is -2 greater than or equal to 0? No, it's not. So since that's false, red is not included. It looks like I highlighted it. This is not included. All right. Last one I chose was 5. So 5 minus 4 over 5 plus 2, and I want to know, is that greater than or equal to 0? So this will be 1 over 7. So it's a positive number, so it is greater than or equal to 0. So all of this interval is also included in my solution set. So I've got two intervals that are included. Remember that you're including your interval to your critical value, not to your test point. So a common mistake is that people would include, like the first interval, they would put -infinity to -3. That's not correct because you're using the test point. You want to use your critical value, right? So don't make that mistake. So the intervals, let me erase some of this to get it out of the way. The intervals that are included are -infinity to -2. And here's another thing we have to keep in mind. The numerator can be 0, but the denominator cannot. So the critical value that you get from the denominator has to be an open circle, meaning parentheses. The critical value that you get from the numerator, the top, can be included if you have the or equal to symbol, which we do. So -infinity to -2 with parentheses, because that was in the denominator, union 4 to infinity with a bracket, because that was in the numerator. Number 21 is similar. Number 22 is similar. Number 23, This is a review factoring problem, so hopefully you can do that one. That brings us to the end of the review. I hope you find this helpful. Good luck on test 5.